returned the endangered Arabian Oryx to the desert of Neom for the first time after a century.
The antelope species is also thought to be the source of the unicorn legend. Its only natural predator, man. The last remaining wild oryx was shot in Oman in 1972.
January 31st, 1982. 10 Arabian oryx stepped onto cracked, dead gravel, a desert so broken, scientists had already given up on it. No water, no shade. Surface temperatures hitting 60 degrees Celsius. These 10 animals hadn't touched wild ground a single day in their lives. Yet within months, the dead desert started breathing again. Not because of million-dollar machinery, not because of government irrigation projects, because of hooves, dung, and a behavior no one had written into any conservation manual. What those 10 Arabian oryx did to that dead sand over the next 40 years.
The oryx is a master at controlling its temperature and at saving liquids. It stores solar radiation during the day in order to consume it when the temperatures drop during the cold nights on the desert.
Rewrote the rules of nature itself. Stay with us, because what the evidence reveals next will change how you see deserts forever. The desert that forgot it was alive. The Jiddat al-Harasis does not look like a place that ever had a story. It sits in the interior of Oman, roughly 300 meters above sea level, flat, gray, and almost completely silent. No dunes, no dramatic cliffs, no winding rivers cutting through red rock. It stretches across an area roughly the size of Switzerland, and from above, it looks like the earth simply forgot to finish the job. Angular limestone gravel over compacted hardpan, broken occasionally by shallow, dry riverbeds that have not carried water since the Pleistocene. That is the Jiddat, a flat, stony plain that goes on until it doesn't. Annual rainfall here sits under 40 millimeters. London receives around 600 millimeters per year. The Jiddat receives less than 7% of that, and most of what does fall evaporates off the surface before it reaches plant roots. The hard pan beneath the gravel is so compacted that water cannot move through it vertically. It sheets off. It pools briefly, then it vanishes. In summer, the ground absorbs heat through the day and radiates it back until midnight. In winter, temperatures swing 35 degrees Celsius between noon and 4 in the morning, hot enough at midday to blister skin, cold enough before dawn to require heavy clothing. Most people, looking at the Jiddat for the first time, would call it dead. That word is close, but not quite accurate. And the difference between close and accurate is the entire point of this story. Below the hardpan, there is moisture, old water trapped in deep soil layers. Unreachable by shallow roots, but accessible to plants that invest years, growing taproots 2 to 3 meters straight down. A few perennial grasses do exactly this. They hold their position in the gravel, barely visible, producing almost no above-ground growth, surviving entirely on what they can pull from deep below the surface. In the shallow wadi beds, the dry channels left behind when the Pleistocene rivers stopped flowing, small herbs and ground plants persist in the marginally better soil conditions. After a rare rainfall event, annual plants germinate, complete their entire life cycle in 3 to 4 weeks, set seed, and die before the ground fully dries again. It is a functioning ecosystem, technically, running on almost no energy input, producing almost no visible output, maintaining itself at the absolute lower boundary of what biology can sustain, but functional.
This plant is totally dead. It didn't store its food underground in bulbs. Instead, it adopted a very different and very drastic strategy.
The processes are still there. The soil chemistry still works. The seed bank in the ground is still viable. The insects that depend on brief plant flushes still emerge after rain and complete their cycles. The system is not broken. It is waiting. What it is missing, and what no one in the conservation community had fully articulated yet in the 1970s, is the animal that had been running it for 1 million years. The Arabian Oryx had lived on the Jiddat since long before any human settlement existed in the region. 1 million years is a number that resists comprehension, but what it means practically is this. The oryx and this landscape had time to develop a relationship far deeper than simple survival. The oryx did not just exist in the Jiddat, it worked there. Every day, moving across the gravel, the animal was breaking compacted soil with its hooves, depositing seeds and nutrients in its dung, stimulating grass growth through grazing pressure, seeding microbial communities through body contact with rocks and soil. The land produced the food. The oryx processed it and redistributed it. The land became more productive as a result. The oryx population grew. The cycle ran. This kind of relationship between a large animal and its landscape is called an ecological feedback loop. It is not visible in any single interaction. You cannot watch one oryx eat one clump of grass and see the desert recovering. The effect accumulates over time, across a whole population, across thousands of square kilometers, across decades. When the oryx disappeared shot to extinction across the peninsula by motorized hunting parties between the 1950s and 1972, the desert did not collapse. It kept doing what it had been doing. Grasses survived in their minimal way. Seeds arrived on wind. Insects continued their cycles. The surface biology held on at its lower boundary. But the feedback loop was broken. The engine that had driven soil aeration, seed redistribution, and grazing stimulation across the entire landscape had simply stopped. The Jiddat kept running. It just stopped improving. What remained was not a dead desert. It was a desert that had forgotten what it was capable of and had no way to remember on its own. Built for a world that almost stopped existing. Look at an Arabian oryx long enough, and you start to see the desert in its body. The coat is white not for aesthetics, but because white reflects sunlight. In an environment where surface temperatures cross 60 degrees Celsius in summer, the difference between a pale coat and a dark one is the difference between surviving the afternoon and not. The horns are long and straight, up to a meter in length, carried by both males and females, not ornamental, functional, used in dominance contests and defense against predators on open ground where there is nowhere to hide. The hooves are wide and slightly splayed, a shape refined over hundreds of thousands of years of walking on gravel and loose sand, distributing body weight across the surface instead of concentrating it at a point, the way a narrow hoof would, preventing the animal from sinking with every step. Adults weigh between 65 and 100 kilograms, medium-sized by antelope standards, large enough to cover serious distance daily, efficient enough in their water use that they can go weeks without drinking, extracting moisture from the plants they graze and from overnight condensation on vegetation surfaces. Every physical feature the Arabian oryx carries is an answer to a specific problem posed by the environment it evolved in. The animal and the landscape shaped each other over a time frame so long it is almost impossible to hold in mind. For most of recorded human history, the Arabian oryx ranged across the full width of the Arabian Peninsula.
The oryx inhabited much of the Arabian Peninsula until it was on the verge of extinction in the 1970s.
Historical records from Arab travelers, naturalists, and Bedouin oral traditions describe herds moving across the gravel plains of what are now Oman, Saudi Arabia, Yemen, Jordan, and parts of Syria, hundreds of animals ranging together across landscapes that could support them, precisely because the animals themselves were maintaining those landscapes. The Harassis people had lived alongside the oryx on the Jiddat for generations. They hunted them, tracked them on foot and by camel across the gravel plain, reading the ground for signs, hoof impressions, dung deposits, the disturbed surface of a recent grazing site. They took animals for food. The oryx population absorbed this pressure without difficulty. It had been absorbing human hunting pressure at varying intensities for thousands of years. The Harassis knew the oryx's movement patterns, its seasonal ranges, the conditions under which it gathered in larger groups, and the conditions under which it dispersed. That knowledge had been passed across generations, because the oryx had always been there to learn from. Then the jeeps arrived. In the 1940s, motorized vehicles began appearing in the Arabian interior in meaningful numbers for the first time. Wealthy hunting parties organized by collectors, aristocrats, and government figures from across the region and beyond began moving into the desert, specifically targeting the oryx. The logistical barrier that had protected the species for millennia had not been the lack of human desire to hunt it. It had been the difficulty of the terrain. A hunter on foot or camel could pursue an oryx, but the oryx could outpace him across open ground and outlast him across distance. The animal had co-evolved with that threat. Its endurance, its ranging behavior, its ability to detect and avoid slow-moving pursuit, all of it was calibrated against a predator that moved at human and camel speed. A jeep moved at 60 kilometers per hour across flat gravel. The oryx had no behavioral response to that. No instinct told it to run from a machine. No evolutionary history had prepared it for a threat that could chase it down in minutes across the same open ground that had always been its escape route. Hunting parties in the 1950s began running oryx herds with convoys of vehicles, multiple jeeps spreading across the plain, cutting off escape angles, driving the animals until they exhausted themselves, then closing in. Single expeditions from this period recorded killing dozens of animals in a day. The population did not decline gradually, it fell off a cliff. Estimates from the early 1960s put the total wild Arabian oryx population across the entire Arabian Peninsula at fewer than 200 individuals. By the late 1960s, field surveys could confirm fewer than 50. The last wild Arabian oryx recorded in the peninsula was shot in the Jiddat al-Harasis in 1972, the same ground where the species had ranged for 1 million years, the same flat gray plain where its hooves had been fracturing hardpan and distributing seeds since before modern humans existed in the region. The species was declared extinct in the wild that same year.
Scimitars went extinct in the wild primarily due to excessive hunting and also the vegetation or the habitat loss that has happened subsequently.
What remained were the animals that a small group of conservationists had seen coming and acted on in time. In 1963, 9 years before the last wild animal was shot, the Fauna and Flora Preservation Society had established a captive breeding program at the Phoenix Zoo in Arizona, drawing animals from zoo collections and the last few individuals that could be removed from the wild before the collapse completed. 9 animals formed the founding population of what became known as the World Herd. By 1972, careful breeding across multiple facilities had grown that captive population to over 100 individuals. The wild oryx were gone. The captive ones existed in enclosures across the United States and Europe, separated from the landscape they had shaped by an ocean and 4 decades of zoo-born generations. Whether that gap could ever be crossed, whether an animal born in Phoenix, Arizona could walk onto the Jiddat al-Harasis and remember what to do, was a question nobody had yet answered. The years we tried everything else. The decision to bring the oryx back was not the first idea anyone had. It was the last one left. Between 1975 and 1980, Oman worked with international conservation partners to answer a question that seemed, on the surface, straightforward. Could the Jiddat recover on its own if the hunting simply stopped? The reasoning behind this approach was logical. The ecosystem had been intact before motorized hunting arrived. The soil was the same, the rainfall patterns had not changed. The seed bank in the ground was still viable. If the pressure that had driven the oryx to extinction was removed, perhaps the land would find its way back without further intervention. Sections of the Jiddat were fenced. Hunting was prohibited across large areas. Researchers established vegetation monitoring plots at regular intervals across both protected and unprotected zones to track any changes in plant density and ground cover over time. The plan was to run this assessment for 5 years, collect the data, and let the numbers tell the story. 5 years later, the numbers said almost nothing had changed. Vegetation density in protected areas was statistically indistinguishable from unprotected ones. No new plant species had established. The sparse perennial grasses that had survived the decades of hunting pressure were doing exactly what they had been doing before the fences went up, holding their positions in the gravel, neither spreading nor dying, surviving at the same low density they had maintained for as long as anyone had been measuring. The ecosystem was not suppressed and waiting to rebound. It was stable at a low level and had no mechanism to move upward from there. The reason, which became clearer in retrospect than it had been at the start, was that the problem had never been hunting pressure on the plants. Plants had not been hunted. The problem was the absence of the animal whose daily movement had been driving the processes that allowed plants to spread seed distribution, soil aeration, grazing stimulation, nutrient cycling. Those processes had stopped when the oryx disappeared. Fencing the land and waiting did not restart them. Nothing in the ecosystem had the capacity to restart them. The land was not suppressed. It was missing a working part. Aerial seeding was the next option considered. Aircraft would distribute grass seed directly across the Jidit, bypassing the need for natural seed dispersal.
Government program that is helping local farmers.
Well, it's a $15,000 grant that helps farmers use a helicopter to plant seeds from overhead,
and giving the vegetation a direct boost in density. The assessment team analyzed the approach against the rainfall patterns of the region and rejected it. The Jidit does not receive rainfall on a schedule. It arrives in short, unpredictable bursts, sometimes one significant event per year, sometimes none at all, sometimes two, in close succession after years of almost nothing. Timing aerial seeding against this pattern was essentially impossible. Seeds distributed before a rainfall event would sit on the hot gravel surface for weeks or months, exposed to temperatures that destroyed viability before moisture arrived. Seeds distributed after a rainfall event would land on ground where the moisture window had already begun closing. In hyper-arid desert, the soil dries fast enough that most seeded plants cannot establish root systems deep enough to survive before the water is gone. The only thing that moves seeds reliably into the microenvironments where germination was actually possible: hoof depressions, dung deposits, body scrape sites where the soil surface was broken and marginally more moisture was retained, was a large animal moving continuously across the landscape. Without that, aircraft-distributed seed had establishment rates close to zero. The third intervention was water. Engineers installed supplemental water points at 2 locations on the Jidit, reasoning that reliable water access might anchor a recovery zone and allow vegetation to establish around it. Birds and small mammals found the water points within days. They concentrated there in numbers. Within a single season, the vegetation surrounding both installations had been stripped bare by the density of animals drawn to a fixed resource in a landscape where water was otherwise almost absent. The water points had not created recovery zones. They had created the most degraded patches on the entire Jidit. Each solution had produced a version of the same result. Add something fixed to the landscape, and the landscape organizes itself around that fixed point, in ways that make things worse, not better. Fence a section, and the missing processes stay missing inside the fence as reliably as outside it. Drop seed from above, and the desert ignores it. Install water, and the desert degrades faster around it. 5 years. 3 approaches. 0 measurable recovery. What the data was pointing toward, and what the conservation teams were reluctant to accept because of how difficult and uncertain it was that no engineered solution could substitute for the animal that had been running this ecosystem for 1 million years. The Jidit did not need infrastructure. It did not need aircraft or fencing or water installations. It needed something that moved, something that covered 20 kilometers a day, breaking soil and depositing seeds and stimulating grasses and seeding microbial communities as a simple consequence of being alive and moving through the landscape. 10 animals and a desert that remembered. In 1980, 9 oryx were selected from the world herd at Phoenix Zoo and flown to Oman.
It was a decision of the international community in the interest of conservation to form a world herd and bring whatever oryx were left here to the Phoenix Zoo.
1 additional animal came from private collections coordinated through the Fauna and Flora Preservation Society. The 10 animals were held in large outdoor acclimatization pens on the edge of the Jidit for approximately 2 years, allowing them to adjust to the heat, the terrain, and the food sources available. On January 31st, 1982, the crates were opened. The lead bull moved out first. He drove his hooves into the gravel, dropped his head, and began pulling at the sparse, dry grass growing between the rocks. The cows spread out around him, pawing at the compacted surface. breaking the hardpan with their hooves, exposing the soil layer beneath. Not one of these animals had ever done this before. They had lived their entire lives on managed ground, with supplemental feed, inside zoo enclosures. No one had taught them to break hardpan. No one had shown them how to use their hooves on a compacted desert surface. They simply did it. The Harassis people, the tribe that had lived on the Jidot for generations and whose ancestors had hunted oryx across this same ground, were hired as rangers. Their knowledge of the gravel plain, its seasonal patterns, its water sources, and its hidden geography was the monitoring system. GPS telemetry at the scale needed to track free-ranging animals across thousands of square kilometers did not yet exist in practical form. The rangers followed the herds on foot and by vehicle, recording movement patterns, birth rates, and range use by hand in notebooks. Within the first 18 months, what the rangers documented changed how the research team understood what they were watching. The oryx were not staying near the release site. They were moving across the full width of the Jidot long-distance directional movements, covering the entire gravel plain within a year and a half of release. More significantly, they were navigating toward rainfall events that had occurred 30 to 50 kilometers away before the research team had confirmed that rain had even fallen in those locations. Somehow, the oryx were detecting moisture or vegetation changes at distances that exceeded any known sensory range. The mechanism by which atmospheric pressure changes, subtle wind-borne chemical signals from wet soil, or something else entirely was not understood. What was documented was the result. The animals were behaving as though they had a map of the Jidot that no captive-born animal should have possessed. They were ranging like animals that already knew this landscape. The desert was doing something to them, or they were doing something to the desert. In those early years,
the landscape of the desert consists of plateaus, highlands, valleys, dunes, having the shades of these colors.
The research team was not yet sure in which direction the causation ran. By 1985, with a second release of additional captive-bred animals completed in 1984, the herd on the Jidot had grown to several dozen individuals, breeding successfully, requiring no supplemental water or feed. The monitoring plots established around the range began showing something the researchers had not expected to see this early. In areas of highest oryx activity, vegetation density was measurably increasing. The four silent forces. Nobody watching those 10 oryx walk onto the Jidot in 1982 would have called it a restoration project. It looked like 10 animals grazing on dead ground. That is exactly what it was, and that is exactly why it worked. The mechanisms that drove what happened over the next 4 decades were not dramatic. No single moment looked like progress. No single day produced a measurable result. But across a growing herd moving 20 kilometers every day, eating, walking, resting, and moving again, 4 quiet biological processes ran simultaneously, compounding on each other, reshaping the soil structure, the plant density, and the ecological function of one of the most hostile environments on Earth. The first thing the oryx did, without knowing it, was break the desert open. Oryx hooves are wide and slightly splayed, a shape refined over 1 million years of walking on gravel and loose sand. Every step on the Jidot's compacted hardpan created a small fracture in the surface. Not a dramatic crack, a microfracture invisible to the eye, roughly the size of a coin. One animal crossing a dry wadi bed left hundreds of them. A herd of 20 crossing the same ground left thousands. Then the rain came. Even 5 millimeters of rainfall, an amount that would barely register in most climates, infiltrated through those fractures, rather than sheeting off the impermeable surface the way it had been doing for decades. Monitoring data from plots set up inside the oryx range showed soil moisture at 30 centimeters depth was measurably higher in grazed areas than in adjacent ungrazed control plots after identical rainfall events. The oryx were not making it rain. They were changing where the rain went after it landed, pulling it down into the soil instead of letting it evaporate off the surface. The second thing the oryx did looked, from the outside, like damage. They grazed the sparse perennial grasses down to 3 to 5 centimeters, low enough that a casual observer would have assumed the plants were being destroyed. The opposite was true. Grasses respond to heavy grazing by shifting their energy away from vertical growth and into lateral root expansion, a process called tillering. A heavily grazed grass spreads horizontally, thickening its root network, increasing the ground area it covers per plant. In the years before the oryx returned,
the Arabian Oryx, a ghost that refused to vanish, a symbol of Dubai's resilience.
ungrazed perennial grass on the Jidit would grow tall, set seed, die back in the heat, and leave bare ground between individual plants. After regular grazing, those same plants spread sideways, maintaining continuous ground cover across a wider area. In a desert where total vegetation cover was being measured in single-digit percentages across thousands of square kilometers, this change compounded into something significant. The third mechanism moved across the entire range every single day. A single Arabian Oryx deposits roughly 1.2 kilograms of dung daily. Each deposit carries viable seeds from plants eaten hours earlier, nitrogen compounds from digestion, and active gut microbes. Moving 20 kilometers a day, one animal seeds 20 kilometers of landscape with material ingested somewhere else. A herd of 20 animals produces 400 kilometers of daily nutrient redistribution. By 1990, when the Jidot herd had grown past 100 individuals, the daily seed and nutrient movement across the range exceeded 2,000 kilometers. Seeds landing in hoof depressions, the small soil excavations created by the same walking movement that fractured the hardpan, showed measurably higher germination rates than seeds deposited on an unbroken surface. The depression held slightly more moisture after rainfall. Slightly more was enough. The fourth mechanism was quieter than all the others. Oryx rub against any raised surface they encounter: rocks, dead shrub stems, sometimes each other. The contact deposits skin-borne bacteria and organic debris directly into the soil at those scrape points. In a hyper-arid environment where soil microbial communities are extremely sparse and take decades to develop naturally, these scrape sites became seeding points for biological activity that the land would otherwise have waited a very long time to recover. 4 processes. Running every day, requiring nothing from anyone. By April 1990, the herd had crossed 100 animals and was ranging across more than 11,000 square kilometers without supplemental water or feed. Vegetation density inside the Oryx range was measurably higher than in adjacent ungrazed land. Perennial grass cover in regularly grazed zones sat above baseline levels that had not shifted during the 5 years of passive protection before the reintroduction. The land was responding, the soil was changing. What had been classified as a dead desert was, by documented measurement, recovering. Then, from late 1996, organized poaching operations began moving into the Jidot, with vehicles not subsistence hunters, but coordinated capture teams taking animals alive for private collectors across the Gulf. By September 1998, the population had been cut from over 400 to approximately 138. By 2007, it had fallen further, to between 65 and 100 animals. 15 years of ecological recovery, dismantled in a decade, by the same method, the same machinery, the same logic that had caused the original extinction. The difference this time was that the knowledge existed to begin again. Eventually, the poaching slowed. The political will held. Recovery restarted slower, more cautious, but built on the same foundation that had worked the first time. 10 animals, 4 mechanisms, no management required. In 2011, the International Union for Conservation of Nature did something it had never done before in recorded history. It moved the Arabian Oryx from extinct in the wild to vulnerable.
These Arabian Oryx are a beautiful sight. Here, they're taking a moment to eat and refuel, preparing for whatever the day brings.
A species had come back from zero. By 2023, wild and protected area populations across Oman, Saudi Arabia, the UAE, Jordan, and Israel numbered approximately 1,220 individuals, rebuilding soil function across thousands of square kilometers of desert that science had written off as permanently dead. 10 animals, one flat, gray, broken plain. No machines, No irrigation, no million-dollar intervention, just hooves on hardpan, dung in the sand, dry grass pulled down to the root, and told, by the pressure of teeth, to spread. The desert didn't need a miracle. It needed the animal it had shaped for 1,000,000 years to come home.